Okay, so this question asks, to integrate x plus 13 over x squared plus 5x minus 6 dx. Let's write it down. X plus 13 over x squared plus 5x minus 6 dx. You can separate x squared plus 5x minus 6 as x plus 6 and x minus 1. And this is on top of x plus 13. On the bottom of. So we're going to use a partial fraction decomposition technique to integrate this thing. So you can write it as x plus 13 over x plus 6, x minus 1 is equal to x plus 6 a plus b over x minus 1. And what we're gonna do is we are gonna get rid of the denominator. So we're gonna multiply x plus 6, x minus 1 in both sides, and this becomes x plus 13 equals a x minus 1 plus b x plus 6. And what we're going to do is put the values in x and find a and b. Let's put x equals 1 first. X equals 1, 14, and a cancels. If you put it in there, if we put it in 1 in there, 1 in a x minus 1, a will cancel out. So this will just become b times 7. So b becomes 2. We have the b value. And plug it in, x equals negative 6. And we get 7 on the left side, and then plug it in, negative 7a. And then if you plug it in negative 6 and b x plus 6, this just becomes 0, so a becomes negative 1. So we have both a and b value, and let's rewrite it. This becomes negative 1, x plus 6 plus 2 over x minus 1, entire thing, dx. Separate that, negative 1, x plus 6 dx plus integral 2 over x minus 1 dx. So this just becomes, if you remember the ln x derivative is same as 1 over x. So this is the same form. So this becomes negative ln x plus 6 plus 2 ln x minus 1. We have that, and then plus c, because there's no bounds for this question. And let's just kind of use our logarithmic properties. This just becomes negative ln x plus 6 plus ln x minus 1 squared plus c. And since there's a negative sign, you can divide that, ln x minus 1 squared over x plus 6 absolute value, and that will be equal to plus c. So this option equals to the option D. So the answer for this question is D. Okay, so this question asks to integrate 2x cubed plus 5x squared plus 8x plus 4 over x squared plus 2x plus 2 squared. Let's write it. 2x cubed plus 5x squared plus 8x plus 4 over x squared plus 2x plus 2 squared dx. So what we're going to do for this question, we are going to use the partial fraction decomposition technique. And what you can do first is you look at the denominator, and it is the squared value. So you can separate this as x squared plus 2x plus 2 plus x squared plus 2x plus 2 squared dx. And then the denominator will be, since it's x squared, it's minus 1 of the denominator power. So this is going to be ax plus b. So the same thing happens to the back part, cx plus d. So we have that. And this 2 value should equal to this value, right? So you're going to write it as 2x cubed plus 5x squared plus 8x plus 4 over x squared plus 2x plus 2 squared equals ax plus b over x squared plus 2x plus 2 plus cx plus d x squared plus 2x plus 2 squared. What we're going to do is multiply x squared plus 2x plus 2 squared to get rid of the denominator. So let's do that. Then this just becomes 2x cubed plus 5x squared plus 8x plus 4 is equal to ax plus b plus ax plus b times x squared plus 2x plus 2 plus cx plus d. Let's do some calculation here. This just becomes ax cubed plus 2ax squared plus 2ax bx squared plus 2bx plus 2b, and then cx plus d. So this just becomes ax cubed plus 2a plus b x squared plus 2a plus 2b plus c, x plus 2b plus d. And that should be equal to 2x cubed plus 5x squared plus 8x plus 4. Okay, so let's do those two equations should equal to each other. So let's find all those a, b, c, d value. So 2x cubed and ax cubed are the same thing. So a should equal to 2. And 2a plus b and 5 should equal to 5. So 2a plus b is supposed to be equal to 5. 4 plus b, because we found a equals 2, equals 5, b equals 1. We have b value, a value. And then 2a plus 2b plus c should equal to 8. So 2a plus 2b plus c is equal to 8. 2a, 4, 2b, 2 plus c. So c becomes 2. We have c value. And then d value. 2b plus d is supposed to equal to 4. 2b plus d is equal to 4, and b is 1. 2 plus d equals 4, d is 2. So we have all those a, b, c, d value. Now let's plug it in there. This thing is ax plus b, so it's 2x plus 1 over x squared plus 2x plus 2 plus c is this, and d, c and d are both 2, so 2x plus 2 over x squared plus 2x plus 2 squared dx, and both dx. So the one that looks exact the same would be the answer choice B. So the answer for this question is B. Okay, so this question asks to find the surface area of the curve. So the curve is y equals sine x, and we know the surface area equation is 2 pi fx square root of 1 plus f prime x squared dx. And yeah, integral, of course. So integral, it's from 0 to pi over 2. 0 to pi over 2, 2 pi, fx is sine x, and f prime x, let's just write this, fx equals sine x, and f prime x is cosine x. F prime x squared becomes cosine squared x, becomes 1 plus cosine squared x dx. So, okay, we have that, and the value that's actually equals to this equation is A. So the answer for this question is A. Okay, this question asks x squared dx over square root of 16 minus x squared, and we have to integrate that. So if you look at the square root of 16 minus x squared, you can remember this is the same thing as a squared minus x squared form. And when you have this equation, you put x equals a sine theta. In our case, a squared is 16, so our x is 4 sine theta. Okay, we have that, and dx, derivative of that, is 4 cosine theta d theta. We have also that, and let's find the bounds. So x equals 4 sine theta, so theta would be sine inverse x over 4. Okay, and then let's plug in the values. Sine inverse 0 over 4 is sine inverse 0. Theta is just 0, so we have the lower bound. And theta equals sine inverse x over 4. Plug it in, sine inverse 2 square root of 2 over 4. Sine inverse square root of 2 over 2. This is pi over 4. So we have the upper bound as well. Okay. I'm just going to write theta on the equations. And we have all those values. Now let's write it. So it's from 0 to pi over 4, x squared, 16 sine squared d theta over 16 minus 16 sine squared theta. And wait, 16 sine squared, and we didn't put the d theta, dx value, sorry. And then times 4 cosine theta d theta. I did not remember that. So 0 to pi over 4, and this becomes 64 sine squared theta cosine theta d theta, and you can group into 16. 1 minus sine squared theta, and this thing becomes 0 to pi over 4. 64 sine squared theta cosine theta d theta over 4, because 16 square root of 16 is 4, and this just becomes 4 cosine squared theta inside of square root, because if you remember it, sine squared theta plus cosine squared theta is equal to 1. So 1 minus sine squared theta is equal to cosine squared theta, right? Which is why you put the cosine squared theta inside of the square root, and square root and cosine squared will be cancelled out. So it's going to be 0 to pi over 4. 64 sine squared theta cosine theta d theta over 4 times cosine theta itself. Cosine theta cancels out, 4 and 64 cancels out, and this becomes just 16. And this will be just 0 to pi over 4, 16 sine squared theta d theta. And if you remember your double angle, I think it's half angle actually. Yeah, double angle, like if you remember, I don't know whether it's like double angle or half angle, but we do know that the sine squared theta is equal to 1 minus cosine 2 theta over 2 equation. So you can use that equation to solve this integral. So let's plug it in. So 0 to pi over 4, 16, 1 minus cosine 2 theta over 2 d theta. Okay, let's cancel out the 2. 0 to pi over 4, 8, 1 minus cosine 2 theta d theta. Distribute 0 to pi over 4, 8 minus 8 cosine 2 theta d theta. And this just becomes 8 theta minus, so sine 2 theta, and then it's gonna be, let's do 4 sine, 8 theta minus 4 sine 2 theta. And it's from 0 to pi over 4. Okay, we have that. And let's plug it in. 8 pi over 4 minus 4 sine 2 pi over 4. And if you plug it in 0 on both sides, this just becomes 0. So you just have to calculate this part. And this just becomes 2 pi minus 4 sine pi over 2, which pi over 2 is just 1. So this just becomes 2 pi over minus 4. So for this answer for this question is D. Okay, so this question asks to integrate 12 over square root of t plus 4t square root of t. Let's write it. 1 over 4, 1 over 12, 12 dt over square root of t plus 4t square root of t. Let's group them into square root of t in the denominator. So this becomes 1 over 12, 1 over 4, 12 dt over square root of t, 1 plus 4t. So in this question, we are going to put as u equals 2 square root of t, because we know dt over square root of t will be denominator of 2 square root of t. So u is equal to 2 square root of t, and du becomes, I'm going to write it as 2t 1/2, so I can show it to you. Du becomes t and negative 1/2 dt, which is same as 1 over square root of t dt. And our u will become u, 2t 1/2. So plug it in u 1/4 power, and let's write it again. U 1/4 value would be 2 1/4 1/2. So this will be just 1/2. So wait, 1/4, 1/2. This is just 1. U 1 over 12. This value will just become 2 1/12, 1 over 2. This will be 2 square root of 1 over 12. So 2 times 1 over 12, 2 square root of 3. So this is 1 over square root of 3. Okay, we have those values. Lovely. And then you can write it as 1 over square root of 3, and then 12 dt over square root of dt over square root of t becomes du, because we found that value. 12 du over 1 plus 4 and square root of t, 1 plus 4t, t is 4t is basically u squared, right? U is 2 square root of t, so 2 square root of t squared is 4t, right? So this is just u squared. So 1 plus u squared. Sorry, I got lost too. So you can take it out 12 outside of the integral. So this becomes 12. 1 over square root of 3, 1 over 1 plus u squared du. And if you remember your inverse tangent formula, tangent inverse becomes 1 over 1 plus x squared. This is basically the same formula. So this just becomes, I'm going to write it all the way down here, sorry. 12 tangent inverse u 1 and 1 over square root of 3. Okay, 12 tangent inverse 1 minus 12 tangent inverse 1 over square root of 3. This just becomes pi over 4, and this just becomes 12, sorry, I forgot to write 12. And this just becomes pi over 6, so this becomes 3 pi, and this becomes 2 pi, so this just becomes pi. So the answer for this question is C. Okay, this question is find the length of the curve given by the equation. Okay, let's write the equation. X to third plus y to third equals to 1. I'm going to write it as y to third equals to 1 minus x to third power. And I'm going to get rid of the 2 third power by multiplying 3 over 2 power on both sides. This is going to be y equals 1 minus x to third 3 over 2 power. And I'm going to find the derivative. dy over dx is equal to 3 over 2, 1 minus x to third, 1 half, and the chain rule, negative 2 third x, and it's going to be negative 1 third, and negative 2 third, and x 3 over 2 can be cancelled out. So it's going to be just negative x, negative 1 third, 1 minus x to the 2 third, 1 over 2 power. Okay, we have that. And if you remember the length equation, it's integral of square root of 1 plus f prime x squared dx. So since we already have the dy dx, we just have to plug it in. Length says 0 to 1 because we are given square root of 1 plus this entire thing squared negative x negative 1 third squared 1 minus x 2 third 1 half squared dx. 0 to 1 square root of 1 plus negative sign will be cancelled out since it's getting squared, and it's gonna be x negative 2 third, and then this is gonna be 2 and 1 half will be cancelled out, so it's gonna be 1 minus x 2 third dx. Let's distribute this 0 to 1 plus x negative 1 x negative 2 over 3, sorry. So this just becomes x negative 2 over 3, and then minus x minus 2 over 3 plus 2 over 3. So this is just 0, right? So 0 power. And negative x 0 power. So something to the power of 0, this is just gonna be just 1. So it's gonna be negative 1 simply. And negative 1 and 1 can be cancelled out. So it's going to be 0 to 1 square root of x negative 2 over 3 dx. And you can write square root as 1 half, so you can write it as x negative 2 over 3 1 half dx. So 0 to 1 x negative 1 third dx. So this just becomes x 2 over 3, 3 over 2, 0 to 1, so it's going to be 3 over 2. So the answer for this question is D. Okay, so this question asks which expression represents the y-coordinate of the centroid of the region of the plane bounded by y equals x squared and x equals y squared. So let's draw it first. So y equals x squared is looking like this, and x equals y squared is looking like this, right? But since this part, x equals y squared, which can be written as y equals plus minus square root of x, y equals negative square root of x, y equals square root of x. So since this part y equals negative square root of x is not bounded by y equals x squared, we're just gonna ignore this part, and we're just gonna use y equals square root of x. And let's find the intersection point. We can find the intersection point by setting those y values equal to each other. which is x squared equals square root of x. So if you just square both values, this becomes x to the fourth equals to x. X to the fourth minus x is equal to 0. X cubed minus 1. X equals x minus 1. X squared plus x plus 1 equals 0. So x is 0 and 1. So the intersection points are 0 and 1. There we go. We have that. And now, when you want to find the coordinate of the y coordinate of the centroid, you have to find the area. So eventually the equation for this y centroid is 1 over a, which is area of the curves, and then the bounds, and then f squared x minus g squared x, and then integrated by dx. Sorry, I'm running out of space. So basically this equation, and we want to find area first, right? So let's do that. So area of the curve is 0 to 1. It's the first region. Let's see. So it's this area, right? Which we can just make it bigger. Which this line is y equals square root of x, and this line is y equals x squared. So when you find the area, it's always the big height minus small height, which big height is y equals square root of x, because which is higher than the y equals x squared. So this is going to be square root of x, bigger height, minus smaller height, x squared, and dx. So that's the area. We have that. And if you look at all those options, they didn't compute it, so you can just leave it like this, a. And then let's find the y value. So y value, y centroid coordinate, is 1 over a. So its intersection points is 0 and 1, 0, 1, fx squared. So in here, fx will be our bigger height, which is square root of x, and gx will be our x squared, and fx squared becomes x, gx squared becomes x to the fourth power. So this becomes x minus x to the fourth power and 1 over dx. And you have to do 1 over 2. I forgot to write it in the equation, sorry. Yeah, 1 over 2 is very important. Don't forget that, like me. So yay. 1 over 2 can be come out from the equation. So 1 over 2a, 0 to 2, x minus x to the fourth dx. So if you look at the option, this just becomes 0 to 1, x minus x to the fourth dx, 1 over 2, and that area, which is where 0 to 1, square root of x minus x squared dx. So this thing, I will just rewrite it. That looks a little ugly. Let's rewrite it, sorry. So this becomes, see, 1 over 2, and then it's 0 to 1, x minus x to the fourth power dx, and 1 over 2, 0 to 1, square root of x minus x squared dx. So which is equal to option E. So the answer for this question is E. Okay, so this question asks to integrate from 0 to 1, 1 over square root of x dx. So 0 to 1, 1 over square root of x dx. 1 over square root of x dx can be written as 0 to 1, x minus 1 over half dx. If you integrate it, this becomes x 1 over 2, and then 2 in front of it, and integrate it from 0 to 1. So let's plug it in. 2, 1 half minus 0, 1 half. This becomes just 2 times 1, and this is just 2. So the answer for this question is C. Okay, so this question asks which statement is true for the following sequence. Let's write it first. A to the n is equal to square root of n plus 1 minus square root of n. So in this question, we can just put this as limit of n goes to infinity. So let's write it as square root of n plus 1 minus square root of n. We want to get rid of the square root, so what we're going to do is we're going to multiply the conjugate. So square root of n plus square root of n divided by square root of n plus square root of n. We are dividing it because originally this was not supposed to be on it, so
if you multiply the same thing and divide by the same thing, it's going to be the same value eventually. So limit n goes to infinity. This becomes n plus 1 minus n over square root of n plus 1 plus square root of n. N and negative n cancels out. So limit n goes to infinity, 1 over square root of n plus 1 plus square root of n. So there we go. And then if the limit actually goes to infinity, this will be just 1 over infinity plus infinity. So 1 over infinity equals 0. So this is just going to 0. So it is convergent. And we have to check it's whether monotonic or decreasing. Monotonic means it's not decreasing and not increasing. So the example for monotonic equations will be something like fx equals 2x plus 3. 2x plus 3 is just, something like 3, and it's just increasing like this. No, not increasing, but like it's constant. That's what I meant. So in this case, we're not sure it's monotonic or decreasing, so what we're going to do is just simply plug it in. So we have limit n goes to infinity, 1 over square root of n plus 1 plus square root of n. So let's plug it in, n equals 1. It becomes 1 over square root of 2 plus square root of 1. N equals 2, it becomes 1 over square root of 3 plus square root of 2. So this is 1 over 1 plus square root of 2, and this is 1 over square root of 3 plus square root of 2. If you punch in the values in the calculator, it will show that it's going to be decreasing. And also, we can know that it's decreasing because the denominator is getting bigger. If the denominator is getting bigger, that means it's decreasing. So the answer for this question is convergent and decreasing, so the answer is E. So this question has 1 over e plus 1 over e squared plus 1 over e cubed plus 1 over e to the fourth power plus infinity. So it's asking whether it's converging or diverging. So let's find the pattern first. S to the n is equal to 1 over e to the nth power because it's 1 over e squared, 1 over e cubed. It's easy to find the pattern. Okay, we found that. And also, this is using the infinite geometric series because 1 over e value is actually less than 1 and greater than, basically the absolute value of the ratio, which is 1 over e, is less than 1. So we can use the geometric series and we can find the geometric series sum. So if you find the geometric series sum, this is, the equation for that is a over 1 minus r, which a is the first value. In this case, we're given first value is 1 over e. So a is 1 over e. R is the ratio that it's repeating, which is 1 over e as well. So this question is 1 over e over 1 minus 1 over e. So 1 over e over e, e minus 1 over e. So this becomes e over e minus 1. So this eventually becomes 1 over e minus 1. So this value actually converges to 1 over e minus 1. There we go. Okay, so this question asks only one of the series converges and which one. So let's look at it. So number A option. So A option is n equals 1 to infinity 1 over square root of n. This is same as n to the half, negative 1 half. Right? So in this case, you can use a p-series test. So since negative 1 half is less than 1, or negative 1 half, or just absolute value of negative 1 half is just less than 1, so this is divergent. This is p-series test. Okay, let's look at option B. N equals 2 to infinity e to the n over ln 2. ln n. So this case, what we're going to do is we're going to do the ratio test. So e to the n plus 1 over ln n plus 1 divided by e to the n ln n. Okay, so you can write e to the n plus 1 as like e to the n times e over ln n plus 1 times ln n times e to the n. So if you multiply those things together, this will be cancelled out eventually if the limit goes to actually infinity. And e to the n will be cancelled out, and there will be just e left, right? So since e value is greater than 1, this is actually divergence. So a and b are not right. Let's look at C option. N equals 1 to infinity 2 to the n power over n plus 3 to n power. So for this question, we are going to use direct comparison test. Sorry. So what we're going to compare to is 2 to the n over 3 to the n, which is bigger than this actual value because the denominator in here is bigger, right? Which you can write this 2 to the n over 3 to the n as 2 over 3 n power, right? And if you want to find the infinite value, you can just put limit n goes to infinity, and this is geometric infinite sum. So x to the infinity is equal to a over 1 minus r. A is, in this case, 2 over 3, because n is 1. And the ratio is actually 2 over 3 as well. So this is 2 over 3 over 1 minus 2 over 3, which is equal to 2 over 3 over 1 over 3. So this just becomes 2, which is converges to 2 value. Converges to value 2, meaning since the bigger one converges, smaller one will also converge. So C is right. Let's look at D and E as well, just in case. So D is n equals 2 to infinity 1 over n ln n. So for this one, we can do the integral test. Integral test 2 to infinity 1 over x ln x dx. We're going to put u as integration by parts, u as ln x, du as 1 over x dx. Oh no, you don't even have to do the integration by parts. It's just u substitution. Sorry. U equals ln x, and then du, derivative of u is just 1 over x dx. So we found out everything, right? So this becomes ln 2, and this becomes infinity 1 over u du. So this becomes ln u, absolute value, ln 2 to infinity integration, ln infinity minus ln 2. So this is just going to be infinity minus ln 2. Infinity minus something small is just going to be infinity anyways. So this one diverges. So this is not right. Let's look at option E. Option E is n equals 1 to infinity and sine 1 over n. So this one we're going to use limit comparison test. Okay, limit comparison test. So we're going to put sine 1 over n in here, and we're going to put 1 over n comparing. So limit goes to infinity, and we're going to use L'Hopital's rule. So this becomes cosine 1 over n times chain rule negative 1 over n squared over negative 1 over n squared as well for the derivation, because we are using L'Hopital. So this thing cancels out, so this just becomes cosine 1 over n, which limit n goes to infinity, cosine 1 over n is just same as cosine 1 over infinity, which is cosine 0, which is 1. So this thing goes to 1, so limit n goes to, oh, my handwriting is bad. Limit n goes to infinity, a to the n over b to the m is greater than 0, so it works for that. But if you look at it, n equals 1 to infinity 1 over n. So this thing, 1 over n to the n or something like that, this 1 over n is actually like, if you look at the p-series test, 1 over n is just n to the, oh, sorry, why did I write n power? So n equals 1 to infinity, let's write it again, 1 over n, b to the n power, right? So this is just n equals 1, infinity 1 over n, right? And if you look at the p-series test, 1 over n is just p-series 1. If p-series is 1, it diverges. Sorry. So this one, E doesn't work. So the answer for this question is C. Okay, so this question asks, assume each a to the n is positive, which one of the following conditions guarantees the series a to the n diverges? Let's look at option A. Option A says limit n goes to infinity, a to the n over 1 over 2 to the n is equal to 1. So for this question, we're going to use limit comparison test, LCT. So LCT says a to the n over b to the n is greater than 0. That's the first condition. So let's look at that. Since a to the n over b to the n, which b to the n is equal to 1 over 2 to the n power, which is equal to 1, which is greater than 1. So the first condition is met. Second condition is you have to find the b to the n value to conclude this thing is converging or not. So b to the n, like we said, it's 1 over 2 to the n power. So if you want to find the convergence, you have to put the series sigma sign and find the sum. N equals 1 to infinity, 1 over 2 to the n power. Since r is 1 over 2 in this case, it's an infinite geometric series. R value is less than 1, so this thing is going to converge. So A is not right. Let's look at option B. A to the n is greater than 1 over n squared. For this question, we are going to use direct comparison test. So direct comparison test says if it's smaller value diverge, then it diverges. Bigger value converge, bigger value converge, then it converges. If it's not this order, it's not going to give you the right conclusion. It's going to be inconclusive. So let's look at that. A to the n is the bigger one, and 1 over n squared is the smaller one. So in order to be diverging, this has to be diverged, right? But 1 over n squared, our small value, is converging because p is equal to 2. And according to p series test, this is converges because p value is greater than 1. So since our smaller value converges, it doesn't tell anything about bigger value. So B, in this case, it's going to be inconclusive. As long as it's not like smaller value diverge and diverge, bigger value converge and converge, if it's not this order, then it's going to be inconclusive. This is the main key exam point that professors like to play around. So make sure to remember it. So C, let's look at that. Same thing, A to the n. Oh, it's not the way. A to the n is less than 1 over n. Okay, 1 over n is our big value. A to the n is our small value. Because 1 over n is bigger, obviously. And 1 over n, if you look at it, 1 over n is going to be diverging by the p-series test. Because p value is equal to 1. If its p value is greater and equal and less than equal to 1, then it's going to be diverging. So since our bigger value diverges, it doesn't tell you anything about smaller value. So the C for the direct comparison test, this test conclusion will be inconclusive because it doesn't tell you anything about it. So C is not right. Let's look at option D. Limit n goes to infinity, a to the n over square root of 2 to the n is equal to 1. Okay, so for this one, we're going to use the limit comparison test. So at least this value is already equal to 1, which is greater than 0. So the first condition is met. Let's look at the b to the n part. B to the n is equal to square root of 2 to the square root of 2 n. And this n can be come out. So square root of 2 to the n in sigma value. And this thing will be diverging because our value square root of 2 is greater than 1. So it's not meeting the infinite geometric series thing. If you remember the infinite geometric series, it has to be, the r value has to be less than 1, the absolute value of it. The absolute value of r has to be less than 1. So this is, if this happens, this is going to be converging. If this happens, r value is, absolute value of r is greater than equal to 1, it's going to be diverging. In this case, square root of 2 is greater than 1, so it's going to be diverging. So it's diverging, which is the answer for this. But we're going to look at the option E too. So option E says limit n goes to infinity a to the n over 1 over n squared. So for this one, we're also going to use the limit comparisons test, and this is equal to infinity. So since limit comparison test says a to the n over b to the n is greater than 0 for the first condition, it's met because it's infinity value. So first one is done. But let's look at the b to the n value. B to the n says it's equal to 1 over n squared. So b to the n 1 over n squared is converging by p-series test. So this thing is converges. So the conclusion is converges, which is not the option that we are looking for. We are looking for the diverging. So it's not right. So for this question, the answer for this question is D.